In this video, we are going to talk about Scikit-Learn's ColumnTransformer, which is going to be a very useful tool for you when you develop supervised machine learning pipelines on real-world datasets using Scikit-Learn. So far, we have talked about different transformations that you can apply on your data. We have talked about imputation, scaling, and one-hot encoding. We have also talked about pipelines. With pipelines, we can chain together different transformations so that we can apply this series of transformations on your data. Once we have this transformed data, we can pass it to an estimator. Now, very often in most applications, we have a variety of features and we want to apply different transformations on different features. Now, you cannot really do that simply using pipelines. In a pipeline, for example, you can chain together different transformations. So you can chain together, say, simple imputer and scaling, or simple imputer and one-hot encoding. But it doesn't really make sense to chain one-hot encoding and scaling, right? You cannot really have one-hot encoder as the first step of the pipeline and scaling as the second step of the pipeline. Because when you have a pipeline like that, when you chain one-hot encoding and scaling in a pipeline, then it will apply these transformations on all columns in your data. And there is no real meaning to applying one-hot encoding to numeric features and scaling to categorical features. So simply using pipelines for this is not going to be enough. And we need something else. Enter Scikit-Learn's ColumnTransformer. ColumnTransformer allows you to apply different transformations on different features. And it does it in a single object so that we can pass that ColumnTransformer object in a pipeline. So let's talk about ColumnTransformer in detail. First, I'm going to use a toy dataset to demonstrate why do we need a ColumnTransformer and how to use Scikit-Learn's ColumnTransformer. Once we know how to use ColumnTransformer, we will apply it on our California housing dataset. So this is our toy dataset. Let's go back to our quiz 2 grade toy classification problem. The problem here is predicting quiz 2 grade. Now note that I have added a few more features to our original quiz 2 grade toy classification problem. In particular, I have added this binary feature enjoy course, which tells us whether the student enjoyed the course or not. Then there is this categorical feature major feature. And the possible values here are computer science, mechanical engineering, mathematics, and so on. So this column is not a numeric column. There are these categories here. Then we have this university years column. This is a numeric column and it tells us how many years the student has spent in university level education. And finally, we have this class attendance feature. In our original dataset, we had class attendance feature, but it was a binary 0-1 feature. Now we have changed it to an ordinal feature. So there are these categories here, excellent, average, poor, and good, but there is some ordering in these categories. So it's an ordinal feature now. Okay, now let's try df.info. What do we see here? We see that for this lab2 feature, we have 2 missing values. There are only 19 non-null values. Okay. So for all other numeric columns, it seems like we do not have any missing values, but lab2 has 2 missing values. If we want to train a Scikit-Learn model on this dataset, what all transformations we need to apply on it? Let's think about it. First, we have all these numeric features, this university years, and all these lab and quiz 1 features are all numeric features. And we see that the scales of this university years feature versus all these labs and quiz 1 grade features, they are quite different. So we want to apply scaling on numeric features. Second, we have this major feature, which is a categorical feature, and we would like to apply one-hot encoding on it. Also, we have this enjoy course feature, which is a binary feature, and again, we would like to apply some kind of encoding on it because Scikit-Learn won't accept this column as one of the features. We need to encode it into numbers. Then we have this class attendance feature, which is an ordinal feature. There is ordering between these categories. For example, excellent and good are closer to each other compared to excellent and poor. Then we have this lab2 feature, which has some missing values, and we would like to apply imputation on this feature. And finally, there is this ML experience feature, which is a binary feature, but it's already encoded into zeros and ones. So we don't really want to apply any transformation on it. So these are the things we would like to apply on this particular data set so that we can pass this encoded data to a Scikit-Learn model. How can we do that? We will be using Scikit-Learn's ColumnTransformer for that. So let's look at an example of applying ColumnTransformer on this toy dataset. Let's look at all these transformations step by step. Okay, so first of all, this is our data. I'm creating X and Y from our dataset. Now, the first step I usually carry out is identifying feature types in our dataset so that we can apply appropriate transformations on them. So let's categorize these features based on what kind of transformations we want to apply on them. Now for simplicity, initially I'm going to drop these features lab2, class attendance, and enjoy course. So I'm dropping this feature, enjoy course, then this lab2 feature which has some missing values, and this class attendance feature which has an ordinal feature. We will look at them in a bit, but initially for simplicity, let's just drop them. Now, among the remaining features, let's identify numeric features. Our numeric features now are university years, Lab 1, Lab 3, Lab 4, and Quiz 1. Remember, we are dropping Lab 2 because it has some missing values. We will deal with it in a bit. Then we have one categorical feature, this major feature. And we do not want to apply any transformation on this ML experience feature. So I'm calling it pass-through feature. We do not want to apply anything. We just want to pass through it. Okay. So this is the categorization of our features based on what kind of transformations we want to apply on them. On numeric features, we would like to apply scaling. On categorical features, one-hot encoding. And for pass-through features, we do not want to apply anything. Now let's create a column transformer for our toy dataset. For that, first we need to import ColumnTransformer. Next, let's create a ColumnTransformer object. In this object, we are going to specify what all transformations we want to apply on what kinds of columns. So we identified that we have two primary types of columns, numeric columns and categorical columns. And we want to apply scaling on numeric columns and one-hot encoding on categorical columns. Let's just forget about pass-through features and drop features for a minute. Okay, so when we are creating this object, we are telling it to apply standard scalar to numeric features, and we are giving some name to this transformation. We are giving this name scaling to this particular transformation. In the next transformation, we are asking it to apply one-hot encoding on categorical features. And we are giving this name one-hot to this particular transformation. So in ColumnTransformer, we have defined these different kinds of transformations. And we are telling our ColumnTransformer to apply different transformations on different categories of features. Now, similar to pipelines, Column transformer also has this convenient make column transformer syntax. And we will be mostly using this syntax because it's convenient and compact. So for that, you want to import this make column transformer from scikit-learn.compose. And with this syntax, now you don't have to explicitly specify the names of each transformation or each transformer in your make column transformer. So we are just telling it to apply standard scalar on numeric features, and the name of this transformation will be lowercase of this class. Then our second transformation is one-hot encoder on categorical features. Now we are also adding pass-through and drop features here. We are telling it to pass through for these pass-through features. So we do not want to apply any transformation on these pass-through features. And we want to drop our drop features. Now, if you do not include this line in this particular column transformer, it would be fine. It would only consider the columns which we specify in column transformer. But when we have this line explicitly here, it kind of makes it clear that these are the features we are not including in our model. We are dropping these features. Okay, so we have our column transformer now. This is how it looks like. This is a column transformer and it has a number of transformers. The first transformer is our standard scalar on numeric features. These are our numeric features. Then one-hot encoder is our second transformer, and we are applying it on this categorical feature. Then we are passing through this pass-through feature, and we are dropping these three columns in this particular case. So that's our column transformer. When we call fit transform on this column transformer object, all the appropriate transformations from this column transformer will be applied on the appropriate columns. And the result of all these transformations will be concatenated horizontally. For example, in our case, it will apply standard scalar to numeric columns and one-hot encoder to categorical columns. It won't apply any transformations on the pass-through columns, and it will concatenate the result of all these transformations horizontally. Now, a big advantage here is that we are building all our transformations in this one object. And this way we are making sure that we won't accidentally break the golden rule. We can pass this column transformer object to a pipeline, and we can have an estimator after that. And we can pass that pipeline to cross-validate, for example. And inside cross-validate, our pipeline and column transformer will take care of only applying fit transform on the training data in each fold and only transform on the validation data. Now let's examine our transform data. Let's first look at the type of our transform data. And the type here is numpy.ndarray. So it's not a data frame. And if you look at the data, it's going to look something like this. So this is our transform data. Now, how can we visualize this transform data as a data frame? Now remember that on categorical columns, we have applied one-hot encoding. So we are going to have more columns compared to our original data frame. So let's first get this list of column names. In our column transformer, our first transformation was applying standard scalar on numeric features. Now, when we apply standard scalar on numeric features, we are not going to have new columns, and our column names are not really going to change. So I'm just having this numeric features as my first few features. Then our next transformation is applying one-hot encoding on categorical features. Now, when we apply one-hot encoding, we are going to have new columns depending upon how many unique categories are there. So we want to get these new column names. And we can do that using this getFeatureNames method of one-hot encoder. But in our case, we want to access this one-hot encoder from our ColumnTransformer object. And we can do that by doing this .NamedTransformers underscore, and then we can specify which particular transformation, which particular transformer we want to access. So in this particular case, we want to access this one-hot encoder transformer. So you can actually look at what all transformers are available to us. Our first transformer is standard scalar, then the next one is one-hot encoder, then pass-through and drop. And we want to access this particular one-hot encoder transformer. And we call getFeatureNames on this one-hot encoder transformer. Okay, so we have our numeric features plus these new one-hot encoded features. And the third one is pass-through features. Now again, for pass-through features, there are not going to be more columns. We are just going to keep the same column name. And so this column names now gives us the list of all columns, all newly created columns. So the first 4 columns are our numeric columns. Then we have these newly created columns from one-hot encoding. And finally, we have this ML experience column. And now that we have our transform data and we have column names, we can visualize transform data as a data frame. And we can see that scaling is applied on numeric columns, and this categorical column is one-hot encoded, and no transformation is applied on ML experience. So this is great. ColumnTransformer is doing its job. So here is the summary of what ColumnTransformer is doing for us. This is our original data. We have some numeric features, some categorical features, and some other features. We want to apply scaling on numeric features, one-hot encoding on categorical features, and no transformations on these other features. And this is our ColumnTransformer. Inside ColumnTransformer, we have different transformers. The first transformer applies scaling on numeric features. Now, after applying scaling, the number of columns are going to be the same, but the transformation is going to be applied, the data is going to be scaled, and we are going to have some different transformed data. The second transformer is this one-hot encoder transformer. We are taking categorical columns and we are applying one-hot encoding on them. After applying one-hot encoding, we are going to have more columns here. And the third transformer here is pass-through transformer. For these other features, we do not want to apply any transformation. So the data is not changing and number of columns is also not changing. So these all things are happening inside this column transformer. And this is our transform data. For numeric columns, the number of columns is going to be the same, but the data is going to be transformed. For categorical columns, the data is going to be transformed, as well as we are going to have more number of columns. For other columns, the number of columns remains the same and the data also remains the same. Once we have this column transformer object, we can pass it to a pipeline. Here I'm creating a pipeline with 2 steps. The first step is our column transformer, which will carry out all the pre-processing of the data. And the second step is this SVC classifier. So this transformed data will be passed to this SVC classifier. Now, you don't really have to call fit transform on this column transformer before passing it to a pipeline. I did it before just to show you how this transform data looks like. But if you don't want to look at this transform data, you just create this column transformer object and pass it to a pipeline. Once we have this pipeline object, we can call fit, predict, score on it, we can pass it to cross-validate, and so on. Here I'm showing you an example of calling fit and predict on this pipeline object. In this particular case, if you pass it to cross-validate, you will encounter a problem. And you will see the explanation for that in the corresponding notebook, which is linked in the description below. So that was a quick introduction to Scikit-Learn's column transformer.